In this example, the motion of a basketball as it leaves a player's hand and passes through the net can be modeled using the equation h equal 2 plus 1.1x minus 0.1x squared, where h in meters is the height of the basketball above the ground and x in meters is the horizontal distance traveled. So for part A, find the height of the basketball. So we start by, to find the height, we will need to equate the x to 0 because it's the only variable within the expression. So we know the expression. So at our x equal 0, so that means h will equal 2 plus 1.1 multiplied by 0 minus 0.1 multiplied by 0 squared. So 0 squared and multiplied by 0, that would give us 2 to be the meter, which in 2 meters, which represents the height when x is equivalent to 0, which is when it is released. So that's part I of the question. Now for part double I, at a horizontal distance of 0.5 meters, so that means we will need to equate x to 0.5 meters. So in this scenario, we say h will equal 2 plus 1.1 multiplied by 0.5 minus 0.1 multiplied by 0.5 squared. So in this scenario, we say h will equal 2.525 meters. So this is the horizontal distance, which would be our answer for part double I. For part B, we're asked to use a model to predict the height of the basketball when it is at a horizontal distance of 15 meters from the player. So in this scenario, we will say x at 15 meters, x will equal 15 in this scenario, and we will plug that into the expression. So that will be 2 plus 1.1 multiplied by 15 minus 0.1 multiplied by 15 squared. So in this scenario, we will plug this value, it will give us h to be equal to minus 4 meters. So in this scenario, we need to also, for part C, we need to comment on the validity of this prediction. So for part C, we need to say that height cannot be negative. So the model is not valid when x equal 15 meters. And this will be our explanation, because it's not possible to have height in negative values. And this will be our answer for this question. In this example, the motion of a golf ball after it is struck by a golfer can be modeled using the equation h equals 0.36x minus 0.003x squared, where h in meters is the height of the golf ball above the ground and x in meters is the horizontal distance traveled. For part A, we need to find the height of the golf ball when when it is struck, and which is I, and I double I is when the horizontal distance is 100 meters. So when struck, x is equal to 0. So that means we start with h being 0.36 multiplied by 0 minus 0.003 multiplied by 0 squared. So in this scenario, it tells us that the height will be 0 when x is 0. So this will be part I. For part double I, when a horizontal distance of 100 meters, that means x will equal 100 meters. So in this scenario, we would have h being 0.36 multiplied by 100 minus 0.003 multiplied by 100 squared. So in this scenario, we would have the height to be equivalent to 6 meters when the ball travels a horizontal distance of 100 meters. For part B, use the model to predict the height of the golf ball when it is 200 meters from the golfer. So for part B, when x equals 200 meters, we take h to be 0.36 multiplied by 200, take away from 0.003 multiplied by 200 squared, so that will give us approximately minus 48 meters. So we need to explain this situation, and comment for part C we need to comment on the validity of this prediction. So we say the model is not valid for this distance, and by this distance we mean the 200 meters, as it predict the ball would be 48 meters below the ground level. So this will be our explanation, that it is not possible to have a negative value when at a distance of 200, as it predicts the ball would be 48 meters below the ground level. And this will be our explanation for this question, and these will be our answers for this question. In this example, a stone is thrown into the sea from the top of a cliff. The height of the stone above sea level, h meters, at time t seconds after it is thrown, can be modeled by the equation h equal minus 5t squared plus 15t plus 90. So for part A, we need to write down the height of the cliff above sea level. So that means in this scenario we will need to equate above sea level, t will equal 0. So that means we would have h equal minus 50 squared plus 15 by 0 plus 90. So that will give us, this term will disappear and the 15 by minus 0 will disappear. So that will be 90 meters. And this will be our answer for part A. For part B, we need to find the height of the stone when t is equal 3. So we say I, t equal 3, so that will give us h will be minus 5 multiplied by 3 squared minus 15 plus 15 multiplied by 3 plus 90. So in this scenario we would have t being equivalent to approximately 90 meters, and this will be our answer when t is equivalent to 3 meters. For part I, when t is equal 15, so in this scenario we would have h equal minus 5 multiplied by 15 squared plus 15 by 15 plus 90. So in this scenario we have when we are substituting 5 apologies, it should be 5 not 15, so that will be 5 here and 5 here. So in this scenario it should give us around 40 meters, and this above sea level, and here it's also above sea level. And now for part C, use the model to predict the height of the stone after 20 seconds. So when t equal 20, we have h to be equal to minus 5 multiplied by 20 squared plus 15 by 20 plus 90. So in this scenario we would have a height of approximately minus 1610 meters. So in this scenario that will be below sea level. So in this scenario we also need, as part C, we are asked to comment on the validity of this prediction, which is part D. So now we say the prediction is incorrect because this height, which is the minus 11610, is below sea level, where the model is probably no longer valid because forces acting on the ball will be different. And this will be our answer. In terms of the prediction is incorrect because the height is minus 1610, which is below the sea level, and the model is probably no longer valid because the forces acting on the ball will be different. And this will be our answer for this question.